Now let's look at the case that we're adding two independent normal random variables. I'm looking for the PDF of the sum. We actually have a nice formula for as many normal random variables as we want to add together. So if x1 through xn are normal random variables with the ith one normal with mean mu I and variance sigma I squared, then the sum is a normal random variable with mean the sum of the means and variance the sum of the variances. So it couldn't be any easier. Now the proof is a little bit long and tedious in the book and uses induction. So I think I'm just going to do an example rather than go through the proof. All right, let's say we roll a six-sided die 60 times. And flip a coin 40 times. Now we win on the die if number rolled is 5 or 6, and let's say win on the coin if we get heads. Let's find the probability that we win at least 45 times. So let's let x1 be die wins and x2 be coin wins. x1 is a binary random variable. We've got 60 trials, and the probability of winning is 1/3 because we win if we get 5 or 6. x2 is also a binomial random variable. We're flipping the coin 40 times, so we have 40 trials, and the probability of success is 1/2. Expected value of x1 is n times p, so 20. Variance of x1 is n times p times 1 minus p, so 20 times 2/3. That's 40/3. The expected value of x2 is 20. Variance of x2 is 20 times another 1/2, 1 minus 1/2, so that's 10. So we can approximate these by normal random variables. So approximate x1 by the normal random variable with mean 20, variance 40/3. And we'll approximate x2 by y2, which is normal with mean 20 also, and variance 10. So approximate the probability that x1 plus x2 is at least 45 with the probability that y1 plus y2 is at least 44.5 using the continuity correction. Now y is a normal random variable, and the mean is the sum of the means. 20 plus 20, I'm sorry, this is, let's say t is y1 plus y2. That's normal with mean 40 and variance 40 thirds plus 30 thirds is 70 thirds. So the probability that t is greater than or equal to 44.5 is the probability that t minus 40 divided by square root of 70 thirds is greater than or equal to 44.5 minus 40, which is 4.5 over square root of 70 thirds. Now this is a normal 0, 1 random variable, and this number is 4.5 divided by, I got the square root was 4.83, and this fraction is roughly 0.93. So the probability that z is greater than or equal to 0.93 is 1 minus the probability that z is less than or equal to 0.93, which is 1 minus, according to the table, that's 0.8238. Approximately, and then this difference is 0.1762. So two normal random variables add together to make another random variable and another normal random variable, and we can use that fact even if we're approximating binomial random variables by two normal random variables. The end.